In this do-it-yourself video, we will show you how to perform an energy and shape calibration in Genle 2000. The scope of this do-it-yourself video is limited to performing a combined energy and shape calibration for a typical germanium detector. This instruction will involve use of a Genle 2000 certificate file to associate known gamma energies with designated channel locations and fitted shape parameters for specific peaks observed in a calibration spectrum. The following demonstration will include steps necessary to obtain a suitable calibration spectrum by counting a radioactive source, assign known gamma energy values to specific peaks in that spectrum, generate new energy and shape calibration functions, save the new calibration parameters to the detector data source, generate a report of the new energy and shape calibration parameters. New energy and shape calibrations should be performed only by knowledgeable personnel and only when there is a valid reason to do so. To compensate for minor gain shifts that cause peak centroids to drift slightly from the desired channel locations, corrective hardware parameter adjustments are relatively easy to perform and are normally preferable to performing a formal recalibration. These adjustments will typically require only a small increase or decrease in the fine gain setting for the detector data source. Mirion has prepared a separate instructional video to demonstrate how these gain adjustments should be performed. It is important to remember that only one set of default energy and shape calibration parameters can be stored within each detector data source at any one time. Use of the File Save option within GAA following completion of a new energy and shape calibration for the open data source will permanently overwrite the previous calibration functions. Before we begin our step-by-step demonstration of how to perform a new energy and shape calibration in Genle 2000, we will make the following assumptions. The detector data source we wish to recalibrate is named DET1234. The actual high-purity germanium detector associated with data source DET1234 has been properly cooled to liquid nitrogen temperature, and high voltage has already been properly applied to that detector. A suitable mixed gamma calibration source is available for use during the calibration. A Genle 2000 certificate file named nbsstd.ctf has already been created for this calibration source and is stored in the /Genle2k/cam files folder. Finally, we will assume that we want our energy calibration function to have a nominal slope of 0.50 keV per channel, with gain adjusted to, so that channel 2665 represents 1332.5 keV. To begin the calibration process, we will open the detector data source named DET1234 in the GAA window. Clear any existing spectral data that might be displayed for a previous count. Open the Acquire Setup dialog window by clicking MCA in the GAA menu bar, then clicking Acquire Setup. If necessary, change the time preset settings to live time in 5,000 seconds. This will allow spectral data to acquire for up to 5,000 seconds, if not intentionally stopped after a short time during our calibration count. After making any necessary changes, click OK to close the Acquire Setup dialog window. Next, open the Calibration Setup dialog window by clicking Calibrate in the GAA menu bar, then click Setup. If necessary, change the Energy Cal tolerance parameter value to 1.5 keV, the tail curve setting to low, and the continuum settings to step and 4 channels. These parameter settings are appropriate for calibrations of high-purity germanium detectors. After making any necessary changes, click OK to close the Calibration Setup dialog window. Position the mixed gamma calibration source near the face of the detector end cap, centered on the axis of the end cap. The separation distance between the source and the end cap should be adjusted to prevent the percent dead time from exceeding 5% during the calibration count. After positioning the source, start an initial count to check the percent dead time value and evaluate the current channel locations of the observed spectral peaks. Allow the spectral data to acquire for approximately 15 seconds, and then confirm that the value for dead time shown in the time info status page is less than 5%. If this dead time value is greater than 5%, move the source further from the detector end cap, then stop, clear, and restart the spectral acquisition. Repeat this sequence of steps until the displayed dead time value is less than 5%. After approximately 30 seconds of spectral data acquisition, examine the current channel location of a high energy reference peak whose desired channel location has been predetermined. The marker info status page can be viewed, and the left and right markers move to bracket the peak of interest to better evaluate that peak centroid location. For this demonstration, we will focus on a spectral peak known to be associated with the 1332.5 keV gamma emitted by cobalt-60 in our calibration source. Assume that our desired channel location for this peak is channel 2665, and the fine gain has already been adjusted to move the centroid for that peak to within one channel of the desired location. If the spectral peak being evaluated is confirmed to appear at the desired channel location, allow the spectral data acquisition to continue for approximately 1,000 seconds. Our demonstration will resume shortly after 1,000 seconds has elapsed and the spectral data acquisition has been manually stopped. Ideally, each peak used during an energy and shape calibration should have a net area greater than 10,000 counts. After using the left and right marker to bracket a peak, the area value shown on the marker info status page provides a good estimate of the net counts in that peak. Spectral acquisition could be manually resumed and allowed to continue until all peaks of interest have net area values exceeding the recommended 10,000 count minimum. However, for this demonstration, we will perform an energy and shape calibration using the existing spectrum in our detector data source. Continue by clicking on Calibrate in the GAA menu bar. Move the mouse pointer to the Energy Full option, and then click on Buy Certificate File. One of our previously stated assumptions is that a certificate file named nbsstd.ctf has already been created for our calibration source, and this file will now be selected from the Genle2k/cam files folder. An energy calibration full dialog window will then appear, listing the gamma energy values stored in the selected certificate file. For germanium detectors, the preferred option for associating spectral peak channel locations with these energy values is the so-called cursor method, involving use of the cursor button in the dialog window. To proceed with this method, highlight the first row in the list box which shows the lowest energy value from the certificate file. For the nbsstd.ctf certificate file selected in this demonstration, the lowest energy value is 88.04 keV. Next, move the cursor in the spectral display area of the GAA window to the centroid channel of the peak that is presumed to match this energy value. It is often helpful to maximize the spectral display and use the expand feature to better determine the proper centroid channel for the peak of interest. Next, return the energy calibration full dialog window and click on the cursor button. The software will calculate preliminary values for the selected peak centroid channel, peak FWHM, and peak low tail factor, and will display these values in the first row within the list box. Note that the next row in the list box will then be highlighted. Use the vertical scroll bar to find and highlight a lower row in the list box that shows an energy value close to the average of the lowest and highest energy values from the certificate file. For this demonstration, we will highlight the row that shows 898.02 keV. Next, move the cursor in spectral display area of the GAA window to the centroid channel of the peak that is presumed to match this energy value. Next, return to the energy calibration full dialog window and click on the cursor button. The software will calculate a second set of preliminary values for the peak centroid channel, FWHM, and low tail factor, and will add these values to the row for 898.02 keV within the list box. Use the vertical scroll bar to find and highlight the last row in the list box, which shows the highest energy value from the certificate file. Next, move the cursor in the spectral display area of the GAA window to the centroid channel of the peak that is presumed to match this energy value. Once again, return to the Energy Calibration full dialog window and click on the cursor button. The software will calculate a third set of preliminary values for the peak centroid channel, FWHM, and low tail factor, and will add these values to the last row within the list box. At this point, the software can calculate an initial set of calibration function coefficients based on the peak channel, FWHM, and low tail values in the 3 populated rows within the list box. Click on the Show button to display the Energy Calibration Curves dialog window. Change the order of the polynomial for the energy versus channel number function from the default value of 1 to 2 by clicking once on the square action button labeled with a plus sign. Using a second-order polynomial for the energy versus channel function is especially important for sodium iodide detectors, but it is also recommended for germanium detectors. Click on the OK button in the Energy Calibration Curves dialog window to accept the initial calibration results and return to the Energy Calibration full dialog window. To optimize the final energy and shape calibration functions, click on the Auto button in the dialog window. The software will then attempt to match additional spectral peaks to the remaining energy values from the certificate file. The Energy Cal tolerance parameter previously specified in the Calibration Setup dialog window will affect this matching process. Any certificate file energies that are not successfully matched to peaks in the spectrum will retain values of 0 for channel, FWHM, and low tail in the Energy Calibration full dialog window. If this occurs, the initial calibration functions might be incorrect, or some of the nuclides originally present in the calibration source might have decayed away. Assuming that all certificate file energy lines were properly matched to the peaks in the calibration count spectrum, click on the Show button in the Energy Calibration full dialog window to redisplay the Energy Calibration Curves dialog window. The final energy versus channel function and associated curve will now be displayed. Selecting the Shape Curve option will display the final FWHM versus energy and low tail factor versus energy functions and their associated curves. If a functional printer is available, the Print button can be used to print whichever curve type, energy, or shape is currently displayed in the Energy Calibration Curves dialog window. Click the OK button to return to the Energy Calibration full dialog window. Click the OK button to close this dialog window. At this point, we need to do one very important final step, assuming we want to save the new energy and shape calibration parameters. Click on File in the GAA window menu bar, then click on the Save menu option. The new calibration parameters are now stored with the detector data source and can be viewed in the Calibration Info status page if that status page is selected as one of the display preferences within GAA. The default energy and shape calibration parameters can also be viewed by clicking on Calibrate in the GAA window menu bar, then clicking on the Energy Show menu option. Finally, a detailed report of energy and shape calibration results can be viewed in the GAA report window, if desired. First, maximize the report window viewing area. Next, click on Analyze in the GAA menu bar. Move the mouse pointer to the reporting option and then click on Standard. Select Analysis.tpl in the template name field and Energy Cal in the section name field. To generate a printed report, check the Output to Printer checkbox and then click on the Execute button. To simply view the calibration results in the GAA report window, leave the Output to Printer checkbox unchecked. Check the Output to Screen checkbox and then click on the Execute button. Use the vertical scroll bar to view the desired sections of the energy calibration report, which includes results for the default energy and shape calibrations. This concludes our do-it-yourself video on how to perform a combined energy and shape calibration in Genle 2000.
For further assistance, please call 1-800-255-6370.